Hi, welcome to Wise Guys. This video is on the addition of vectors, and it's just a second video basically on the addition of vectors. So here we are, we have two vectors, 120 volts at 32 degrees, which is here, all right? So there's our 32 degrees and our 120 volts, and let's call this vector A. And we have 50 volts at 240 degrees. We know that this point here is 0 degrees, here we're at 90 degrees, 180, so we go another 60 degrees to get to 240 volts. So that's where the 50 volts is, right here. Let's call this vector B. There's our 50 volts. And this angle here is 60 degrees. So we know we have 240 entirely here to go from here to here. We want the reference angle, which is the angle that's against the horizontal axis. So we take our 240 and subtract the 180, all right, in order to get this piece. And the reason for that is we're trying to solve for what's happening in this triangle. So let's just draw these vectors a little longer so it's easier to work with. And we want the y component of vector B, and we want the x component of vector B. So we can see that here is our B in the x direction, excuse me, and this vector here is our B in the y direction. And when we're solving for by, we'd be solving for this side, excuse me, this side of our right angle triangle. And when we look at our vector A, we see that we can just draw a line straight down here to get the x portion of A, which is here. So there's AX. And then we draw a line just directly perpendicular to the y-axis to get A in the y direction. So we're solving for A, the x and the y aspects of A. So there's AX here, AY here, and we also have B, and we're solving for the x portion of B and the y portion. And then in the end, we will be adding those up. So let's start by solving for, let's start with vector A. If we wanted to solve for x, we can see that, or AX I should say, we can see that it is adjacent the 32 degrees. So then we know that the hypotenuse here is the 120 volts. So adjacent and hypotenuse, we could use the cos to solve for AX. So the cos of 32 degrees equals AX over the hypotenuse, which is the 120 volts. So now we want AX by itself, so we multiply both sides by 120 volts, and we end up with AX equals 120 volts times the cos of 32 degrees. And we end up with 102 volts. And rounding up to 3 sig figs, which in some sense doesn't make that much sense because we have 2 sig figs here and here. But let's just go with 3 sig figs. Now we're solving for AY. We can see that AY is this side, the same length as this side of the right angle triangle. So this piece here then is also essentially AY. We can see that this side is opposite the angle. We know the 120 is the hypotenuse, so we can use the sine to solve for AY. So AY then equals 120 volts times the sine of 32 degrees, which equals 63.6 volts. Now we're going to move on to this triangle. And again, we want BY, which is the part of this vector that's in the y-axis. And again, this is our vector right here. We want BX, which is the x portion of the vector. If we want to solve for BX, we can see that it's adjacent our reference angle of 60 degrees. So we can use cosine again. So BX over B is the cos of 60 degrees. So let's write that out then. The cos of 60 degrees equals BX over the 50 volts. So BX equals 50 volts times the cos of 60 degrees, which equals 25 volts. Now we're going to solve for BY. BY is here, but we know that it is the same length as the opposite side of this triangle, all right? So then we can say that BY, this length here, is essentially BY. So then BY over our hypotenuse is the sine. So we can use the sine to solve for this. So then this becomes 50 volts times the sine of 60 degrees, which equals 43.3 volts. Okay, so now what we do is we take this information here and transfer it to a new x and y axis, all right? So here we have our x and y axis. We know that AX is 102 volts. So there's AX, which is 102 volts. We have AY, which is a positive, and again, the AX is a positive 102 volts, and the AY is a positive 63.6 volts. So here's AY, and that's 63.6 volts. Now we also have to remember that BY is negative and BX is a negative. So they're moving on the negative x-axis and the negative y-axis. So we need to put them in that way. So then BY is down here, and that's our 43.3 volts. And our BX is going in this direction, and that's our 25 volts. Okay. So now what we're going to do is add these up. We can see that, oh, let's just do this. We can see that in the x direction, so let's put this up here. We can see in the x direction we have a positive 102 and a negative 25. So we subtract those numbers and we end up with a positive 77 volts. And in the y direction we have a positive 63.6 and and a negative 43.3, excuse me. So we end up with a positive 20.3 volts, right? So this is our resultant essentially in the x direction. This is our resultant in the y direction. And what we want is the final resultant, right? So we know we have some voltage in this direction and some in that. And in the end, our resultant is here, okay? So that is our resultant. And when we look at this, we see basically that we have, let's redraw this triangle here. So our 77 volts is here. Our 20.3 volts is here, which is this piece here, 20.3 volts. And this is our resultant. So we can see we can use Pythagoras in order to solve for the resultant. So the resultant then is the square root of 20.3 squared plus 77 squared, which equals, let me see, where did that go? Calculator. 20.3 squared plus 77 squared equals, and then square root. Of course, it helps to turn the calculator on. So 20.3 squared plus 77 squared. We end up with 79.6, so we'll go with 80 volts, all right? So we end up with a resultant of 80 volts. And in order to find theta, we can see that, and theta is always the angle that's against the horizontal, so the reference angle. So we want this angle here. We can see that the 20.3 volts is opposite the angle, and the 77 is adjacent. So then we could use inverse tan. So tan to the minus 1 of 20.3 over 77. So theta then equals second function tan 20.3 divided by 77. 14.7, so let's go with 15 degrees. So we end up with 15 degrees. So then in the end, we end up with this resultant, which is our 80 volts. Whoops. 80 volts. And we have an angle of 15 degrees. And that right here is the final answer, all right? 80 volts at an angle of 15 degrees. Okay, so that video has been brought to you by Wise Guys. I hope you have a good day. Take care.